Let's take a look at a kinematics problem involving both gravitational and spring potential energy. So we have a vertical spring launcher. So our spring is vertical here rather than horizontal. So we load this by placing a mass on top, compressing the spring a distance of 21 centimeters, 0.21 meters, and then we release it from rest. And our object has a mass of 0.046 kilograms, and our spring has a spring constant of 45 newtons per meter. How high above the launcher is that mass going to be able to rise? Now, it's all about, in this problem, choosing a good place to call zero potential energy. That's the key. And my recommendation, anytime you have a spring, is to choose the uncompressed location of the spring to be zero potential energy. So if this is zero potential energy, as I compress the spring, I increase potential energy in the spring, but decrease the potential energy due to gravity. So looking at the end point, my spring would be fully uncompressed, so there'd be no potential energy in the spring. At its highest point, the object would be stopped, so there's no kinetic energy, and my final potential energy would be the mass of my object times the strength of gravity times the height above the launcher. Now, if I release it from rest, again I'd have no kinetic energy, but my spring potential energy would be 1/2 times the spring constant times my compression squared, which is a positive value. The gravitational potential energy would be the weight, mass times the strength of gravity, times that compression, but it's negative, right? We went down in height. So our initial potential energy would be 1/2 times the spring constant times the compression squared minus the mass times gravity times the magnitude of that compression. So if I set those two pieces equal to each other, well, I just have mgh on the final side, so I can divide everything by the weight. The weight cancels out on the second term. So the height then is going to be the spring constant times the compression squared divided by 2 times the weight minus the distance we compressed that object. So I have 45 newtons per meter times 0.21 meters squared. I divide it by 2. I divide it by 0.046 kilograms. I divide it by 9.8 meters per second squared. And that gives me a value of 2.2 meters minus the 0.21 meters that we've compressed. The spring gives us a distance of 1.99 meters. So to 2 significant digits, it would be 2 meters above the uncompressed length of the spring. Thanks for watching.